Inclusion is not about making something extra that we stick on to our already made lesson. It's about this designing the learning from the start in a certain way.
We need to design our learning experience that we offer to our students to include everyone. It's not about technology. It's about making our students feel comfortable, to allow different ways of participation, and to reduce the fear of making mistakes, because by making mistakes, it's the best way to learn. You don't need to be experts in technology. You only need to feel comfortable guiding your students. And this is where educators shine.
Welcome back to Europass Teacher Academy Teacher Talks on YouTube. My name is Susan Gagliano. I'm a teacher trainer at Europass Teacher Academy in Florence, Italy. And today I am very happy to introduce my colleague, Nicholas Moudouros, who is speaking to me from Nicosia in Cyprus. And he is the director of the Europass Teacher Academy in Nicosia, and is also the director of the Emphasis Center, where you are doing some incredible work that I think our listeners are going to be very interested in on inclusive STEAM. Nicholas, would you just tell us a little bit more about you, just where you come from and how did you get interested in all of this?
Yeah, thank you so much for having me today, Susan. Really excited to be here with you discussing a very interesting topic. So my background is in computer science and data communication systems. And my passion is education. So I design and I deliver training courses for both students and also educators, mainly in STEAM education. In digital skills, emerging technologies, we are talking about AI, virtual reality, game-based learning, 3D printing, 3D modeling, video game design, and drone coding.
And for anyone who might not know, is it possible that there might be some listeners there that actually don't know what STEAM stands for?
STEAM, it's an acronym. It stands for science, technology, engineering, arts, and maths. So it takes everything that has to do with sciences, including arts, and brings it together in a very nice package.
And you specialize in particular in making STEAM more inclusive. And this was very interesting to me because a lot of the teachers that we work with at Europass Teacher Academy, and in between teaching courses on conflict management or how to create more inclusive environments in general for all kinds of learners, there are a lot of teachers who actually worry about the very things that they would like to do to make something like STEAM more inclusive. They talk about the fact that it actually excludes some of their students. And I was wondering, I think you have some interesting solutions that you will offer during this talk together. And so when we talk about inclusive STEAM, what does that actually look like in practice?
Very good questions. When we're talking about inclusive STEAM in practice, it all boils to creating learning experiences where every student can participate and can contribute. It's not about technology. It's about making our students to feel comfortable, to allow different ways of participation, and to reduce the fear of making mistakes, because by making mistakes, it's the best way to learn. So in traditional classrooms, we will have some students feeling left out because learning sometimes is very theoretical or it's paced. So STEAM comes and changes these. It brings hands-on learning, it brings creativity, it brings flexibility. So students can engage in different ways depending on their strengths. And I always want to focus on one specific aspect of STEAM, which is not the science part, but is the A in STEAM, which stands for arts. So by adding this aspect, we bring something more to the table, something more to the classroom. We bring creativity, we bring storytelling, we bring design aspects, and this helps to bring students who may not connect with pure technical or scientific subjects.
Oh, that sounds like an amazing opportunity. Also, for the teachers to be able to think outside the box and do some cross disciplinary work. I can imagine lots of opportunities there. So, when you are talking about the fact that you make this much more accessible, you're getting science and math outside of just the textbook, and you're turning it into something hands on. I imagine that you need to use labs, that this is a totally different kind of space that you would have to use. And so, what can you tell us about these STEAM labs? Is this something that like normal schools would be able to do? And what does a STEAM lab look like?
Okay, a STEAM lab can be many things. One thing that I say to the teachers that they come for training specifically in STEAM is that you can start with very limited resources. So you can use equipment which is basically recyclable materials, paper, carbon, plastic cups, plastic bottles. And in this way, you can create a project which includes sustainability in STEM education. But there are also a lot of free tools that can use. To name a few, use Scratch for coding, Tinkercad for designing, highly efficient tools for video game design so students can create their own worlds. And all these are free tools that if you have a computer lab in your school, you can easily utilize this as a STEAM lab. And of course, to leave some room for experiments. So we just need to push at a certain point the desks left and right, create groups, create teams, and they can work in an open space. So starting a STEAM lab, it is not as challenging or demanding as some might think.
So, at what point does the STEAM lab or does STEAM, how do we make it more inclusive?
Okay, that's a very important question.
Yeah.
So to make STEAM labs inclusive, we need to focus on some key principles. First, we start simple. We do not overwhelm students. We begin with small tasks. We build upon them. For example, a simple activity that we can do is to design a smart energy saving classroom system. That might sound like a mouthful, but we can start very simple. We can ask our students, how can we reduce energy waste in our classroom? So they will look around. They will say, okay, we forgot the lights turn on when we went for a break. So, okay, this is one idea. We start putting it on paper. No technology yet. We just identify the problem and we think of possible solution. So second is we focus on learning by doing. So when students build something, they understand much faster. So here, after we do the brainstorming and the design, we create a simple prototype. We need a light sensor, an LED, and basically we say, okay, if there is no light, then switch on the LED, else keep it switched off. And this can be done again on a very simple tool, a very basic simulation, or just drawing it, it would be enough. Another aspect that we have in STEM is that we assign different roles. So not all students need to do the same thing. One can do the coding, the other one can do the design, one can be the manager and organize the team. So students work in teams with roles. And as I said before, one student can design the idea, can make the sketch, can make the concept, and another one will be the engineer. They will put the components together, the sensors, the LED. One will be the programmer, the coder, who will write simple logic, and one person of the team or the whole team, they present the idea. So everyone participates based on their level. And finally, and this is the crucial part, we need to connect these activities with real life problems, sustainability, and energy. So the problem is real. We need to save energy. We need to think about sustainability. So the students understand that this is something that actually matters. And at the end, when they present their solution, it is not important how advanced the system is, but that every student has contributed, every student has understood the concept, and that they felt part of the process. So this makes learning much more meaningful and inclusive at the same time.
Yes. And have you found, when working with teachers, have you been able to brainstorm with them some really cool ideas? And do any other ideas just come to mind? Some practical examples of what you have, maybe even the teachers have brought to you that you hadn't thought of?
There are a lot of examples, and there are a couple that we often do in the classroom with students and with teachers. So one, I can think of two. One of them is a simple example of a project that I call Please Mind the Gap.
Please
So
mind the gap.
yeah, does it ring a bell?
Yes, it does. So when we say mind the gap, it's when we're talking about getting off of the subway, for example, the underground
Exactly,
or the
exactly.
train.
So, yeah. So what is this challenge? So basically, we take two desks, we
Mhm.
make a gap between them, and the task of the students is to create a small robot or a small car with something that is available in the classroom, and their task is for the robot to pass on the other side.
No.
Yeah. So we follow a methodology. I'm also a Lego certified educator. So there is a methodology by Lego with the 4 C's. So first you connect with a real world example. That's why I mentioned the Please Mind the Gap challenge. Then the students, they design, they create, they are built. So it can be from Lego pieces, recyclable material that they have in the classroom, and they test their build. So they try, they fail, they try again, and this is the contemplate. So they see on the previous iteration, let's say, of their prototype, if it worked or not. So they make changes, and when they succeed and their robot passes to the other side, then we continue, which is the 4th C. So how do we continue? We build upon previous knowledge and previous skills that they gain. So I just increase the gap between the two desks, and the students, they need to put in practice what they did before. So they might say, okay, I can make changes to my current car, or we need to build a new one, guys. So this is one example that you introduce mathematics, you introduce gravity, you introduce physics. You have problem solving. They work as a team. Each one has their role: the programmer, the designer, the engineer, the tester, and the manager of the team. And this is one example. Another example we need to say is that STEAM education is not only for science teachers. This type of methodology can be used by any discipline. So another practical example that we do with teachers and with students is a little parenthesis here. Cyprus is unfortunately a divided island. So
Yes.
there is a wall that divides the two sides, and it is a very interesting to see this division in the island. And
Mhm.
what we are doing with the students is to create a barrier, a wall in splitting a desk in two. So
Ah,
Yeah, and we can use again recyclable materials. We can use paper. We can use carton, and so on. And we have one student sitting and sticking his face in front of the wall, and we ask another student on the other side. So, can you see what is the other student is doing? His facial expression, is he smiling, is he sad, is he angry? So they say no, we cannot do, there is a barrier. Okay, how can we bring the barrier down? Let's build something to demolish the barrier that splits us. And they create a contraption. Either it can be a catapult to throw down the barrier, or yeah, or another card that will break the barrier. And once they do this, they reveal the other person. They reveal their emotions. So this can be done by history teachers. This can be done by social science teachers. We introduce also socio-emotional learning in STEAM.
I was going to say, this sounds like something really interesting. So imagine that you and I, we have this barrier between us. And this is a situation that you have in Cyprus. But I think that you would find many of us can relate to this, even if there is not something as official as a barrier like that. But how many times are there barriers, even in our schools, barriers that have to do even with cliques, different groups of kids. And I love this idea of combining this with social and emotional learning. And so some
Exactly.
of the best ideas you saw is like catapults, or they would make some type of car that could ram through it, and they would be very motivated to see what was on the other side.
Exactly. Exactly.
Wonderful ideas. And I'm just curious, what is one of the most interesting things sometimes when the teachers come to you and these are some things that you've proposed? Have there been any ideas that really surprised you that the teachers would come up with? You know, where you were listening to that and you were like, I wouldn't have even thought about that. Like, do you find that the teachers really blossom when they have the possibility to work with these, when they open up their minds?
Yes, there were cases where we were designing video games for young students to use, and they said, okay, can our characters speak in different languages? I said, yeah, there is the option to record voice. So if you can record something in French or in Italian, we can use it and we can have a language lesson. Or if we to combine it with music. So if our sensor would see a specific color, then it will play a specific music tone. So we introduce music elements. And if a specific tone is played, then a door can open, which reveals another treasure or another project. And these are very interesting ideas that the teachers brought. And uh, if you have a speciality in a specific topic, and if you are introduced with these, let's say, basic tools, you can take them and you can take your teaching at another level.
That
And
is amazing. Especially, I'm thinking about how it happens in secondary schools, where we really start traveling on very different railroad tracks, I would say, and the teachers tend to feel, of course, very comfortable in their expertise. But what you are also bringing into this with the inclusive STEAM lab is, how do we get the teachers to work together in a more inclusive way as well, which is something that the kids really feel it. So it's what you're talking about here too, is not just doing experiments, but designing learning so that every student can participate meaningfully, and maybe without realizing it, they're also getting support in other subjects, or they're somehow approaching other subjects in a way that's new to them. Maybe during the curricular lessons, they don't even like that subject, but through STEAM, they find some other avenue. Some of this, though, it sounds expensive. I mean, is it something that schools Some lower resource schools that have a lot of other issues that are much more pressing. These children, maybe the actual school building is old and the equipment is old. Is this possible to apply in a low resource school?
This is actually a very common concern that I have with colleagues, teachers. But what I always tell them is that inclusive STEAM does not require expensive equipment. As I mentioned you before, they can start with any material that is in their classroom. So teachers can start with paper-based design activities, like we said earlier, with a car made out of recycled materials. We can have simple problem-solving tasks. We can use free tools like Tinkercad and Scratch and Unity. And we can also introduce hardware that are low-cost tools like Microbit or Arduino, and sensors that they just cost a few cents or a few euros. But as I said before, the key is not technology; it is the structure of the activity. So even without hardware, even without devices, teachers can have their students design systems, solve problems, work in teams, and this already creates a STEAM experience by its own.
Yes, I'm thinking about the fact too that when you were talking about some of the free tools, I think, there are a lot of strategies that you're talking about. One of the biggest mistakes that we might that teachers might make, is overlooking the fact that all around us in schools we have materials that we are eliminating, or we have problems that need to be solved. And we think that it's, I don't know, the administrator's job to solve it. Or I'm thinking about things connected to food waste. You were talking about making the classroom more energy efficient in terms of, electricity. But there are definitely, or sometimes redesigning even the school playground. Sometimes the playground has become a really sad place, and they want to incorporate maybe a small school garden. And I'm thinking, as I'm listening to you, that this is where STEAM comes into play, and it's not always up to the teacher or the administration to reinvent the wheel, that we have these brilliant people in our classrooms who actually they're much more able to think outside the box than the adults are. The adults see a lot of obstacles that kids don't see. I'm thinking about the use of artificial intelligence, a lot of controversy in how to use it in schools. Some of our top selling courses at Europass right now are about artificial intelligence. And from your point of view, what is it that you see could be the role of artificial intelligence in creating these STEAM labs? Also, with a lot of the restrictions that, rightly so, the EU has put in place. And so, what are your thoughts on that?
That's an excellent point. So AI and new technologies in general, they can play a very strong role if they are used correctly. So we need to be always very careful when using these technologies. So with artificial intelligence, it is a powerful tool. We need to be educated. We need to be aware of the capabilities, of the restrictions, of the dangers of using AI in a way that it is not suitable. But AI has the benefit of helping to personalize a learning path, to help us to detect issues that once they appear later on, it will be too difficult to see. So we need to be very well prepared, very well educated in order to do this. As a participator of various European projects that involve education, we are currently working on two very interesting projects that have to do with artificial intelligence and STEM. One has to do with, it's called EduTain STEM. So it will be a tool for teachers to design STEAM experiences, taking under consideration the needs of the classroom. So each student will be getting a personalized version of the same lesson plan, even if they are working in teams.
Huh.
And the teacher will be designing this by setting goals. The AI system will give additional suggestions, but the final okay would be given by the teacher to finalize the course. And this course will be sent to mobile devices of the students, and the students will be able to follow through STEAM projects, ask questions to the AI system for simplifying or giving more examples, and the AI system will inform the teacher of what is happening in the classroom and if the teacher needs to intervene. So this is one way of using
Huh.
AI. Another project that we are currently working on is to use AI to assess the possibility of early school leaving in schools based on the demographics of the schools, of the area, of the background of a student, taking, of course, under consideration strict GDPR legislation and the European AI Act legislation as well.
And yes, and then you were also in virtual reality, for example, because that's something that lots of schools and the kids get very excited about using the virtual reality goggles. And yes, and I was wondering if that's something that also has a role here.
Yeah, this virtual reality allows students to experience environments that they cannot access. So, one thing that we do with our students is to visit secluded areas like the Great Wall of China, or visit the International Space Station, or go to a different planet. We also think of ways to improve our life here. So, one project that we do with our students is for them to imagine their ideal neighborhood, their ideal city. So we start by again brainstorming. Okay, what is your idea of a perfect neighborhood or a perfect city? They start discussing no pollution, no cars, a lot of green, having the sun but not too hot, or not a lot of rain. So, okay, we put this down, and then we go to a tool that we use to design VR simulations, which is again a free tool, and they start building their ideal city, their ideal neighborhood. And it's one thing just looking at it on a computer screen, but it is a different experience if you immerse yourself and see that this is a world that I would like to live in. Or yeah, it has its ups, it has its downs. So they comprehend and they understand what they need to change in their society, in their city, in their neighborhood to make it better. So yeah,
Beautiful. I
yeah.
love the aspect. I mean, I love this fact too. The inclusive nature of this, as you are describing it to me, is having to do also with the fact that the students and the kids, they can travel to places that otherwise they would not be able to see. And how many times have we thought in some of our subjects like history and geography that when it's just description, it's a sort of a flat description on your textbook and it doesn't penetrate, whereas you really grasp the attention of those learners who suddenly, when it's a 3D experience and immersive, and you can almost smell what it's like to be in this place. And I can't even imagine what that would have been like for a student like me, where it was, if it wasn't experiential, it didn't seem to stick as well. And I'm thinking now about then what are, in all of your experience, what are some of the biggest challenges that they face?
I would say the most important one is confidence, and I have many colleagues coming to me and say, Nicolas, I'm not technical enough, or this really sounds too complicated. There are, of course, also challenges like limited resources or limited time, and that is why I always tell them is to keep these activities simple, provide a clear structure, a clear path, and of course, as a teacher, to be able to spare some time to be educated, to have practical training, and that's why we are here as Europass to help the teachers. And something that I always tell to them is you don't need to be experts in technology. You only need to feel comfortable guiding your students, facilitating the process. And this is where educators shine.
So it sounds like what you're saying is be prepared as an educator to also be surprised at what your own students develop, to not worry too much about. I think the whole idea of what you're talking about in STEAM is that we don't know what will
Exactly.
happen. That we are looking for some interesting problems to chew on, but that
Mhm.
we stay with this very scientific mindset of let's see what happens. And that can really, butt up against what we might think traditionally in teaching is that we need to have the plan, we need to know how it's going to go. And instead, this, again, I keep going back to teacher motivation, that I'm even getting excited and thinking about things that I could do with some of my teaching in how to bring a bit more of how you can hook the students who are maybe a bit more scientific and mathematical in the topics that I talk about, and how to involve the ones who are less scientific and mathematical by hooking them with much more relational, social and emotional issues. Huh. And so you were talking about that teachers need to dedicate a bit of time to training. And I know that at your center, that is really kind of your specialization in Nicosia, that's where you have all of the spaces available, maker spaces, you have all of the equipment. And so the teachers must really have an immersive experience, and just be amazed at the things that they didn't know were possible. And yes, tell us a little bit about what.
This is actually the case, but as you mentioned earlier, there are some schools that are lacking the resources, so we do not exclude them. It is inclusive STEAM, and this is why we offer to the teachers some ready-to-use activities with minimal equipment. Of course, everything it's hands-on, not much theory involved. And from our experience as STEAM educators, because we also have our young students from primary and secondary schools to offer them real classroom examples. The goal for our trainings is that once the training has finished and the teachers, they go back to their countries, they go back to their schools, they can immediately apply what they have learned. And going back to the confidence part, confidence does not come from just reading about it, does not come from the theory. Confidence is earned by doing.
Exactly, that practical, that you experienced it, you touched it, you had fun making it, and then that enthusiasm just spills into the classroom. And as you said, the confidence. And what do you think? First of all, I can't thank you enough for this conversation. And I think the teachers are really going to want to know now, what direction are we going in? What do you see in your crystal ball as the future of inclusive STEAM?
Of course, as we mentioned before, AI plays a quite important role. I see, as I mentioned earlier, more personalized learning, and this being a tool for the teachers to help them connect better with specific students that they learn in a different way. Also, there will be a shift of teaching in general to focus in more real world challenges like
Aha.
sustainability, like the environment. We already see our world changing and not changing to the best, it's changing to the worst. So we need to have our students jump on these and offer solutions from now, and as well to see more accessible tools for the schools, more accessible tools for the teachers. But the most important thing, in my opinion, will remain the same, that we need to design our work, our learning experience that we offer to our students to include everyone. This is the main aspect that I want to see in future inclusive STEAM. Yeah.
We have our teachers definitely have more and more students with very diverse learning needs, with diverse socioeconomic backgrounds. There are many students who don't speak the native language very well. There are all kinds of ways that you have diverse needs. And I have to say that before our conversation, I was thinking of STEAM labs as something a little more elite, or something a bit more, in this attempt to keep pushing the, let's say, the science and technology onto students, because that's what we need in the future. And what you're saying is, no, what we need in the future are thinkers. What we need are people who are not just thinking someone else is going to solve this problem, that we are going to be part of the solution. And that's a very hopeful message, that we can conclude this wonderful talk on this note. And some of the tools that you mentioned, we will also be including in the description of this YouTube video, in case anyone was interested in some of the free tools that you mentioned, and also the European project that you are involved in, because I would imagine that there's going to be lots of opportunities to access some of the research and development that is emerging from this project. And we don't have to reinvent the wheel, teachers. There's already a lot of great information out there, and sometimes we just need to connect it together. And so I think the whole idea is that this inclusion is not about making something extra that we stick on to our already made lesson. It's about this designing the learning from the start in a certain way. And so, Nicholas, we on behalf of Europass Teacher Academy here on these teacher talks, I can't thank you enough for being with us. And I encourage all of our viewers here, if you have any specific questions for Nicholas, we will also include his email address. And if you have any questions in the comment section, drop them in, and both Nicholas and I will be monitoring to see if there are any questions, even just concrete ideas, and we would be happy to help. So, Nicholas, I'll let you get back to your busy day, and thank you so much for being here with us.
Thank you for having me, Susan.
It was a real pleasure, and hopefully I'll see you in person real soon.
Sure.
All right, and thank you all for being with us, and we will see you next week for a new edition of Europass Teacher Talks. Thanks for being here with us.